we are going to see how we can implement singleton pattern in Java. Singleton pattern restricts the instantiation of a class and ensure that there is only one instance in the Java virtual machine. We use this pattern to avoid unnecessary instantiation of instances because instance creation is a bit heavy operation in Java. And why to create unnecessary objects when one object can suffice? There are many use cases for that, like logging, the driver object, the caching object, or the thread pool. They're all using this pattern. If you look into the JDK, like the runtime instance or the desktop instance in AWT package, they're also implemented in this way. Language like Scala has inbuilt language support for singleton pattern, which Java does not have it yet. But then we can use some techniques to easily implement singleton. Let's have a look on those techniques. First of all, the constructor is private so that you cannot use the new operator outside of the class. Then have a public, sorry, private static final variable, and then instantiating that final variable here itself. So what will happen when the class will be loaded by the class loader, the instance will be created during the loading time here itself. Java class loading is inherently thread safe. So even if in multi-threaded environment, you will always have a single instance of this class. Now you just need to get a public static method to expose this instance. Let's call it get instance. The drawback of this approach is the instance will be created irrespective of the fact that this instance may or may not be used from outside. And since this instance is creating during the class loading time, this approach is called an eager initialization. Another drawback of this approach is you cannot do much here, but you can always have a static block if you want to do something extra. And instead of having the initialization of this variable here, I can always have it here. So let's also do some exception handling. Then I cannot have this is as final. Then I can do the instantiation here. So this approach is same like the previous approach. The only difference is you can have a static block and then you can do something extra that you want to do. So the second approach is eager initialization with a static block. But in both the approach, the instance is really created during the class loading. So if you want to delay the instance creation until the point when you really need it, we can implement in a different way. So you will always need a private constructor, and then we can have a inner class. And within the inner class, we can have a private static final variable of demo class and do the instantiation here itself. And then we can have public static methods to expose the instance. Now, if somebody calls demo class dot get instance, then he will get the instance from here. The benefit of this approach is that since the class loading of inner class is by default lazy, so when demo class is getting loaded by the class loader, it will not load the inner class. That means during the class loading, this instance will not be created. So it will only get created when you are asking for a member of this inner class. So what we are doing here is that we are delaying the instantiation until the point when we actually need the instance. By default, it is also thread safe because I am doing it here during the class loading. So when I call this instance method, then the inner class will be loaded because we are asking for a member from the inner class. This is called implementation. Now let's look at the next one, that is lazy, and which is used most of the time. Constructor is private. So what we're doing here, we are only instantiating when the singleton object is not yet instantiated or it's null. The problem of this approach is not thread safe. So this will only work in a single threaded environment. In case of multiple threads are running and somehow more than one thread can call this get instance method at the same time, then you may end up having more than a single instance of this class. We can test that one by running in a multi-threaded environment. So let's create multiple threads and run threads at the same time. Now I need to provide a runnable instant implementation. So I'm using a Lambda function for that. So now I can just call this and I'm going to print demo class dot hash code. And I just need to start the thread. So if I run this code, you'll get the threads. So if you see it here, the hash code is different. That means that you are having multiple instances in the JVM. So this approach of implementing a singleton is not thread safe. So now we are going to look at how to make it thread safe. We can easily make it thread safe just to make this method as synchronized. So the thread has to wait for the other to finish. And that's how you will always have a single instance. So, but the problem of this approach is you will get a lock on the whole object just to get the singleton instance, which is a bit of a overkill. So you just only need to make sure that no two thread execute this method when the singleton variable is not initialized. When it is initialized, then we do not need to really have the lock. So the lock is only required for the first time this object is getting initialized. But in this approach, we are getting the lock all the time, which is not handy. So to improve this approach, what we can do instead of using a synchronized here, we can also use a synchronized block. So what we are doing here, we are once the singleton this instance is initialized, you don't need to do execute this block. You just get it because it is already there. So you just need to make sure that when it is getting initialized, it only gets initialized once. And then you can achieve this using this code. So this is a thread safe approach to get or to implement a singleton pattern. So now you can execute the code as many as number of times. You will always end up the same hash code. Always. So this is a better way of having a singleton pattern using the synchronized keyword. Let's look at the next option, which is using an enumeration or the enum. So let's have, if I make this class, instead of a class, if I use an enum and have only one member in that enum, that means that this enumeration has only one instance. So by this also we can always implement a singleton pattern. So we can check this one. Okay, so what we need to do, we just need to do this. So this is the instance. If we just run it, so this is how we can also implement a singleton pattern using the enum construct within Java itself. Because if we have only one member, then it will make sure that there is only one instance.